Welcome to Brain Vision.
In this problem, there's a block that is sliding along a surface that has a horizontal spring that has a constant of 600 newtons per meter, and it's undergoing simple harmonic motion, and it has a period of 0.4 seconds and an amplitude of 0.2 meters. As the block slides through its equilibrium position, half a kilogram of putty is actually dropped on top of the block, and we're trying to figure out what the new period and motion is going to be and what the new amplitude is going to be. Before we can figure out the new period and the new motion, we have to figure out what the mass of our block is without the putty. And we're going to use the equation T equals 2 pi times the square root of mass divided by the spring constant. And we want to rearrange this to solve for mass. So we'll have mass equals T squared times the spring constant divided by 4 pi squared. And then substituting in our values, we have 0.4 squared times 600 divided by 4 pi squared. And we get that our mass equals 2.43 kilograms. So now if that's the original mass of the block, then to find our new period, we're going to take the mass of the block plus the mass of the putty. So our new period is going to be T equals 2 pi times the square root of 2.43 plus 0.5 divided by our spring constant of 600, and we get that our new period equals 0.44 seconds. All right, now we're going to find the speed that the block was moving before a collision. So we'll have velocity equals xm omega, where omega, so we make that omega initial equals 2 pi over our initial period. So plugging those values in, we get that our initial velocity is going to be 0.20 meters times 2 pi divided by our initial period, which is 0.40, and that gives us an answer of 3.14 meters per second. And since there's conservation of momentum, we can find our velocity after our collision, after the putty is dropped on. So our V final is going to be our V initial, our initial velocity, times the mass of our block divided by the mass of the putty plus the mass of the block. And we get that when we substitute in those values, we have 3.14 times our initial mass, which is 2.43 kilograms, divided by 2.43 plus 0.5, and we get that our final velocity equals 2.60 meters per second. So that is our final velocity. And this will help us find our amplitude, because velocity equals omega times amplitude, and again, omega is equal to 2 pi over t. So we have our velocity equals 2 pi over t times our amplitude, and we have 2.60 equals 2 pi divided by our new period, which is 0.44 seconds, 0.44 times our amplitude. And solving for our amplitude, we get that amplitude equals 0.18 meters.